Hello, Professor. I'm SongziCao, and my N number is N19920310. And in problem 3, we got a digital signal 1 or 0 is transmitted through a noisy channel. The received data may be different from the signal sent out. And suppose the transmitter sends out 0 with probability 0.6 and 1 with probability 0.4. When 0 is transmitted, the receiver receives 0 with probability 0.7 and 1 with probability 0.3. When 1 is transmitted, the receiver receives 1 with probability 0.2 and 1 with probability 0.8. Like the picture. And in first question, find the probability that data 0 is received. We can so there is two events can get this result. The first is the 0 is be transmitted, and we got a correct result. The probability is 0.6 multiply 0.7. And another event can get this result is that we transmit 1 with uncorrected result is 0.4 multiply 0.2. These two events can get a result of data 0 is received. So we add there together. We can get the probability that data 0 is received equal to 0.442 and 0.08. The result is 0.5. So the probability is 0.5. And in second question, find the probability of error. The probability there is also two events can get this result. As this problem said, the probability that is received when 0 is transmitted. This probability is 0 is transmitted, so is 0.6 multiply 0.3, we can got 1, and this 0 is the mistake, is error, is a part of the probability of error. And the second part is that 0 was transmitted. The second part is 0 is received when 1 was transmitted. So we get 0.4 multiply 0.2. We get 0. 0 received, but when 1 was transmitted is 0.4 multiply 0.2. So we add these two events together is 0.18 add 0.08 equal to 0.26. So this is the answer, I think. And in next question, problem 5. We suppose 100 people are waiting for a blood test for cancer disease, and the probability that for one person the test result is positive equal to 0.1. And there are two methods. In method 2, we divide 100 people into 10 groups with 10 people in each group. we can consider these 10 groups separately. And in first group, we mix 10 people's blood and test that mixture. If the result is negative, so we only test one time. If the result is positive, we have to test these 10 people's blood one by one. Now, the number of the tests become 1 at 10 is 11 times. So, we have to calculate the probability of the group has no positive blood and the probability of the group has positive blood. And because one person the test result is positive equals 0.1, and this events every peoples are independent, so the probability for the group has no positive blood equal to 0.9 to 10 times is equal to 0.349. And so we can get the probability of the group has positive blood equal to 1 minus probability of the group has no positive blood is equal to 0.651. Then we can get the number of the group tests equal to 0.51 multiply 11 at 0.349 multiply 1. Because we have 10 groups, so we have to multiply 10. Then we got the result is 75.1 and nearly 76. So we get the answer. On the average, the number of the tests we need to do by the second method is 76. That's all. Thank you. And I am SongziCao, and my number is 199203110. Thank you, Professor.